Essentially, I'm the leader of a project that's called the StormSense Project in Hampton Roads, Virginia. It encompasses a variety of different municipal partners in Hampton Roads, Virginia, including Newport News, Norfolk, Virginia Beach, Portsmouth, Hampton, York County, and the city of Williamsburg. So between all of those individual groups, this is just a smattering of separate cities that have very similar problems that they face, specifically related to tidal flooding, but also storm surge-induced inundation and precipitation-induced inundation. So what's kind of cycling through on the screen here is basically talking about the scalability and measurability of our approach. Two of these are primary focuses of the Global City Teams Challenge. And essentially, the way that we measure the differences in these different types of floods are, of course, the same way that anyone really would care, about what happens when there's a flood. They want to know, is my house going to be flooded? Is my car going to be flooded? So naturally, they want to know where the water's going to be, how long is it going to be there, and then when is it safe to go back, once the water is receding. So based on that, we covered this with vertical and horizontal accuracy, and then ultimately we used that with the reaction and response of individual citizens within these areas to specifically cover the interests of those individuals and whether their interests mainly lie with their property or with their human life or safety. So this is kind of the general concept behind the project is the hydrodynamic model that I've developed, and that's covered on this next slide over here. Yep. So on this monitor here essentially shows an anticipated deployment scheme for a variety of these different types of ultrasonic sensors that we have available here. So not only are the sensors that we have available capable of providing information related to specifically what the water level is, but also it will incorporate a variety of different harmonic frequencies that will be able to predict water levels up to 36 hours in advance of a storm event, and also compound that with existing operations and observation data collected by the USGS and the National Oceanic and Atmospheric Administration to compound that with water level setup over time due to wind-driven features in major storm events. So a lot of our interests here specifically ride on the fact that we want to be able to provide citizens with water level forecasts in advance so that they can make timely decisions based upon either their routes that they follow to work each day, but also specifically how they can better protect and secure their assets. I've got some of our partners here. I'd like to take a time to introduce them if we've got a moment here. So this is Rob Jessen here from the city of Virginia Beach. This is Tammy Organsky from the city of Newport News, and Kyle Spencer from the city of Norfolk. And all three of them are the Geographic Information Systems managers of each of their local municipalities. And naturally, they're the logical partners for this type of project because the model's outputs are GIS rasters, which are basically interactive maps that show people where the water levels will be and what they will be up to 36 hours in advance. Then these GIS managers can then provide that information to emergency managers and others that can help individual citizens make timely decisions based upon decisions that are important for them to make each and every day based upon flood levels local in each of their local jurisdictions.